this section we will see the computing framework. Actually IoT is Internet of Things, which is connecting the various devices around the globe by using internet. So the important part of IoT is computing framework for processing the data, and the most famous computing are the fog and cloud computing. IoT applications use both frameworks depending on application and process location. In some applications, data should be processed upon generation, while in other applications, it is not necessary to process the data immediately. The instant processing of data and the network architecture that supports is nothing but the fog computing, and collectively they all are applied for the edge computing. So cloud computing is nothing but like we are trying to access and store everything on the cloud, and the main thing is that security is also we are providing because everything is present on the cloud. Then comes the ubiquitous computing. So in the ubiquitous computing, it is also called as ubicomp because where the computing is can appear anytime and everywhere, whereas in ubiquitous computing can occur using any device in any location and in any format. So the user interacts with the computer, which can exist in different forms including the laptop, computers, tablets and terminals in everyday objects. The underlying technologies to support the ubiquitous computing include the internet, advanced middleware, operating system, mobile codes, new materials, location positioning, and etc. Whereas in ambient computing, it is also called as the ambient intelligence. That is nothing but it refers to electronic environments that are sensitive and responsive to the presence of people. Ambient intelligence is a vision of future of consumer electronics, telecommunication and computing. So the ambient intelligence and autonomous control do not necessarily require the internet structures. However, there is a shift in research to integrate the concepts of IoT and autonomous control with the outcomes towards the objects. Which objects? The objects that are driving force for autonomous IoT. Most of the works related to IoT exploit the capabilities of cloud computing to perform the analytics and return the outcome to the IoT devices if needed. So the attempts are going because we want to bring some level of intelligence and machine learning at the resource constrained devices, edge and fog computing nodes. So in the future, IoT may be a non-deterministic and open network in which the auto-organized and virtual objects will be interoperable and independently dependent on the context, circumstances or environment. So the ambient intelligence paradigm builds upon the pervasive computing, ubiquitous computing, profiling, context awareness and human-centric computer interaction design. So these technologies that are embedded, that are nothing but many network devices are integrated into the environment. Context aware means these devices can recognize you and your situational context. Personalized, that means they can be tailored to your needs. Adaptive, they can change in response to you. Anticipatory, they can anticipate your desires without conscious mediation. Then comes the fog computing. So, fog computing is applied to migrate the information from data centers tasks to the edge of the servers. So, the architecture is built that is based on the edge servers. IoT is generating an unprecedented volume and variety of data, but by the time of data make it way to cloud for analysis, the opportunity to act on it might be gone. So fog is a new model for analyzing and acting on IoT data. It is either called as edge computing or fog computing. It analyzes the most time sensitive data at the network edge, close to where it is generated, acts on IoT data in milliseconds based on policy, sends selected data to the cloud for historical analysis and longer term storage. So, the next that comes is the edge computing. In this architecture, the processing is run at distance from the core toward the edge of the network. This type of processing enables data to be initially processed at the edge devices. Devices at the edge may not be connected to the network in a continuous manner, so they need a copy of data for offline processing. Edge devices have different features such as enhancing security, filtering and cleaning of data, storing local data for local use. Then comes the big data cloud computing. So, handling the volume, variety, and velocity of IoT data requires a new computing model, and the main requirements are minimize latency because milliseconds matters when you are trying to prevent the manufacturing line. Analyzing data close to the device that collects the data can make the difference between the disaster. So, minimizing latency is the main requirement. Then, conserve network bandwidth. So, it is necessary because in critical analyzers we do not require the cloud scale processing and storage. We have to observe the network bandwidth. Then comes the address security concern. IoT data needs to be protected both in transit and at rest. So the security and monitoring is important. Operate reliability, as it is very widely and increasingly having the uses by the citizens, so it is necessary that it should be safe and in critical infrastructure. So all these are the main requirements. Then comes the distributed computing. It is distributed computing. So the architecture is designed for processing high volume of data. In IoT applications, the sensors generate the data on a repeated manner. Big data challenges are encountered, and to overcome this phenomena, the distributed computing is designed to divide the data into packets. And it is done because the smart city is one of the primary application of IoT, which is basically dependent on this distributed computing. So this is all about the computing framework. In our next section, we will see the essential IoT technologies. Thank you.